Hello friends, welcome back to Edupedia Word Videos, your destination to free education. In this video, we'll be learning how to solve quadratic equation by factorization method. Friends, before starting this method, let us know when the product of certain number of terms is equal to 0. Friends, we know 1 multiplied by 0 is 0. 100 multiplied by 0 is again 0. 0 into 99 again 0, and 0 into pi is nothing but 0. So either the second term was 0 or the first term was 0 in a product of two terms, so that the output is 0. Thus, if we have two terms x and y and their product as 0, then either x will be 0 or y will be 0. Let us now move on to factorization method. Friends, in this method we define two terms, product and sum. If we have a quadratic equation as ax square plus bx plus c equal to 0, which is the general form of quadratic equation, the product will be c into a, that is constant term multiplied by coefficient of x square, whereas sum will be b, that is coefficient of x. We'll be expressing the sum b as the addition of the factors of this product. Let us see how. Let there be an equation x square plus 5x plus c 6 equal to 0, a quadratic one. Product here is 6 into 1, that is 6, and sum is 5. On performing the prime factorization of 6, we'll see that 2 into 3 is also 6. Similarly, if we see negative factors, then minus 2 into minus 3 and minus 6 into minus 1 is also 6. Why? Because these two negative terms on product or multiplication will bear a positive resultant sign, and 3 into 2 will be 6. Thus output here will also be 6. Now we will pick two terms of each of the product and will see whether their addition is this sum or not. The first product is 6 into 1. If we add 6 plus 1, it is 7, which is not equal to the sum defined by us. If we pick 2 plus 2 into 3, then the addition of this term is 5. If we pick minus 2 into minus 3, then their addition is minus 5. Similarly, minus 6 into minus 1, their addition, that is S here, will be minus 7. So our sum is attained by this particular product, that is 2 plus 3 is 5. Therefore, the given quadratic equation, say denoted by Q, will be expressed as this sum is broken into these two terms, that is 5 is decomposed as 2 plus 3. Now open the brackets and we will get x square plus 2x plus 3x plus 6 equal to 0. The next step is to take whatever term can be made common from two pairs, that is this first pair and this second pair. X square is x into x, and this term is having 2 into x. Therefore x can be made common and we are left with x from the first part and 2. Similarly here 6 is 2 into 3, therefore we can take 3 as common, and the left part is x plus 2 equal to 0. Now from these two terms we can take x plus 2 common and get x plus 2, x the residue of the first part, and plus 3 the residue of the second part, equal to 0. Now we have established that we have found out that if product is 0, then either first term is 0 or second term is 0. Now here the product is 0, which means either x plus 3, x plus 2 equals 0 or x plus 3 equals 0. This will bear us x equal to minus 2, whereas the second part will bear us x equal to minus 3. So by factorization method we have developed the solution of this quadratic equation as x equal to minus 2 and x equal to minus 3. Let us study one more example on factorization method. Under root 2x square plus 7x plus 5 under root 2 equals 0. Friends, product here is 5 into under root 2 into under root 2, that is 5 into root 2 into root 2 is 2 equals 10. Its factorization will be 10 into 1 comma 1 into 10, which is one and the same thing, negative 1 into negative 10, 5 into 2, minus 2, minus 5 into minus 2, and so on, whereas sum is 7. Now if we pick the first product, 10 plus 1 is 11, which is not equal to our sum. Similarly, minus 1 plus minus of 10 is minus 11. which is not equal to 7. If we pick 5 into 2, we'll get 5 plus 2 as the sum, which is equal to 7, the sum required by us. Therefore, this 7 of the given quadratic equation, say Q, can be break down as 5 plus 2. Now decomposing these brackets into two terms, we get under root 2x square plus 5x plus 2x plus 5 under root 2 equals 0. From the first pair, we can have x as common and are left with under root 2 into x. For the second term, x is common and hence 5 is left. From the second pair, this 2 can be expressed as under root 2 into x. Thus we can take under root 2 common from these both terms and are left with under root 2x plus 5 equal to 0. Now both the pairs are having this terms in bracket as common. Thus under root 2x plus 5 can be taken common and x from the first part is left as residue, whereas under root 2 is left as residue from the second part. Now product is 0 if either first term is 0 or second term is 0. That is, under root 2 x plus 5 is either 0 or x plus under root 2 is 0. This will give us x equal to minus 5 over under root 2. Whereas this part will give us x equal to minus root 2. Thus, by factorization method, the solution is minus root 2 or minus 5 by under root 2. That is, these are zeros or roots of the given quadratic equation. Let us have a statement based question which says find two numbers such that the product is 182 and sum is 27. Friends, let the two numbers be x and y. The second part of the question says sum, that is x plus y, equals 27. Whereas the first part says their product, that is x into y, is 182. From the first equation, we can have y's value as 27 minus x. If we put this value in the second equation, we will get x into 27 minus x equals 182. Opening the brackets will lead us x into 27 minus x into x equals 182, or 27x minus x square minus 182 equals 0. Generally, we make the coefficients of x square as positive on dealing with quadratic equations. Therefore, take minus 1 common from all the terms. That is, 27 can be written as minus 1 into minus 1 into 27x. X square can be written as plus x square into minus 1. And 182 can be written as plus 182 into minus 1 equal to 0. Or we can have minus 1 common and are left with minus 1 into 27x, that is minus 27x, and plus of x square after taking minus 1 common, and here it will be 182 equal to 0. If we take this minus 1 on right hand side, 0 divided by any number will be 0. Thus we will get x square minus 27 plus 182, 27 of x equal to 0. So this is the quadratic equation. We can solve this by factorization method and we'll get the required numbers. Let us solve it. The product here is 182 into 1, which is 182, which is 2 into 91 equal to minus 2 into minus of 91, and 91 is 13 multiplied by 7. Thus 91 can be further written as 13 into 7, or we can have the factorization further as 13 into 2 into 7, that is 14, or minus 13 into minus 14, or 26 into 7, or minus 26 into minus 7. Now sum is minus 27. If we take the positive terms, we will never get sum as negative, because for having a negative sum, at least or the bigger term must be negative. So all these terms can be rejected by just viewing the terms. If we take this product, then minus 2 plus minus of 91 is minus 93, which is not equal to the sum. If we take these terms, then minus 13 plus minus of 14 is minus 13 plus 14, which is minus 27. So this is the required pair. So given equation, that is x square minus 27x plus 182 equal to 0, the minus 27 can be broken in these two terms, that is minus 13 and minus 14. And we will get x square plus minus 13 minus 14 plus 182 equal to 0 of x. So x square minus 13x minus 14x plus 182 equals 0. From this pair we can have x is common and are left with x minus 13. Similarly, from this pair we can have minus 14 is common, and from here x is left, and 182 equals 13 into 14, because 91 was 13 into 7, so 2 into 91 is 13 into 7 into 2, that is 13 into 14, or minus 13 into minus 14. Minus 14 has been taken as common, so minus 13 will be left over here. Taking x minus 13 common, we are left with residue as x and minus 14. So either x minus 13 equals 0 or x minus 14 equals 0, which gives us x equal to 13 or x equal to 14. Now from this part, if x equal to 13, y is 27 minus 13, that is 14. Whereas if x equal to 14, y is 27 minus 14, that is 13. So the two numbers are 13 and 14, whose product is 182 and sum is 27. So that's all for now, friends. Thanks for watching Edupedia word videos.